Hi guys, welcome back to my YouTube channel. So last class we have detailed discussed about the R's complement and R minus 1's complement. So we know that how to calculate R minus 1 complement and R's complement. So this we have saw for the decimal systems. So similar to decimal systems, we have other systems like binary, octave and hexadecimal, right? So let's see how to find the R's and R minus 1's complement for other systems. So let's take a base as 2. So if base is 2, then this is called as a binary system, right? So it's binary system. So for now, just to know how to calculate it. So in the next lecture or in this lecture ending, I will let you know why we need complement, why these kind of complements, what is the use of it, how these kind of complements are implemented in our real microprocessor chips, and how these are handled in the CPUs. Everything will be seen there. So let's take example of 1010. So if you guys know what is the decimal equivalent of this, please post in the comment section. So this is R is equal to 2 and number of bit is equal to 4. So how to find R minus 1's complement? We first start from R minus 1's complement because the R's complement, how to find R's complement is that is 2 power 1. So 2 power 4 is the 16. So that is can't represented by the 4-bit system. So that's why we first find the R minus 1's complement and then we will plus add 1 to there so that we will get R's complement. So this is how we will be doing. So 2 power 4 minus 1 is 15. So 15 can be represented in decimal by 1111. So we need to subtract this one 1010, the decimal system, which is decimal system, right? So if we subtract it, it will be 1, it will be 0, it will be 1, it will be 0. So if we need to find R's complement, which is nothing but 2's complement here. So this is we can also call as a 1's complement because R minus 1 is 1. So R complement is a 2's complement. So just we need to add 1 in the R minus 1's complement or 1's complement. So if we done it, if we add it, then it will become 0, 1 because 1, 1 is 2, right? So 2 can be represented as, here it is 1 and 0. So the carry will go here. So that will become as 1 here, 1 and 0. So this is what the complement value. So here you guys noticed a similarity here that this is the given number and this is 1's complement. So here you see every bit in this example number given is toggled here. So in a binary system, we need to find out R minus 1's complement. We can simply toggle all the bit. For an example, 1100. This is the number which is R minus 1's complement, which is nothing but 1's complement, which is equal to 0011. If we add 1 to this, then we can simply act this as a, here it also be, here will 1 come, here also another 1 carry goes, so 1 0. So this is the 2's complement. So this is a simple way. In a binary we can directly calculate the R minus 1's complement, which is 1's complement and 2's complement. So let's see how to calculate the complements in the R, which is equal to 16, that is hexadecimal value. So if we take R is equal to 16, this is hexadecimal, right? So which one is, first we can calculate this R minus 1's, which is 15. So 15 is nothing but 15 F's complement because 15 is represented in hexadecimal as F. So if we calculate the F complement, then we will be finding F, 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 F. The number that they given is that 1A, 2F. So let's subtract it. So 1A, 2F. So F, F, that will be directly cancelled. So that will become 0. So in F, we have subtract two values. So then we have to go downwards. So that will become E and then D. So if we subtract two number, then that will be D. So F minus A. F is 15, A is 10. So remaining is 5. Okay, F is 15, 1. So remaining is 14. So 14 is represented by E. So which is the F's complement. If you need to calculate the that is a 16th complement, or this is a 16 complement here, the exact R's complement here, then we have to add 1 here. Okay, so this is hexadecimal, so that's why represented as 16. So this is how we will be calculating the hexadecimal, decimal and binary, everything. The R minus 1's complement and R's complement are calculated. Okay, so this is an important thing, like how to calculate each things. Why we need these complements? So this is an important question that we have to discuss here. So why we need? So in CPU, we know that there will be 3 components will be there. One is that it is ALU, arithmetic logical units, and internal memory, that is caches, internal memory, and registers. Okay, so CPU has only these three parts: ALU, arithmetical logical units, with it for doing logical and mathematical operations. So internal memory, so which will have some kind of storage, and registers are also used for that. We can calculate, we can combine this both, because register is also one kind of memory. So these are the parts that we have. So there is another one part, that is control units. So this is the major parts where that will do mathematical and logical operations, like operations. These operations, the inputs are kept and inputs are stored in these kind of memories, like internal memory, which is nothing but registers are catchy. These operations are handled by the control units. Control units only give input to the system, like whether to add, multiply, or from where to get the input. So those kind of details are taken from here. Okay. So if we need to add two numbers like 1 1 1 0 1 1 1 0, it can be directly done by the operation units. But subtraction, which is some kind of deviation, right? So here is addition. For the addition, we need to write one logic. So one logic will be there. So in order to do the subtraction, there we need another one logic, that will be second logic. So in the ALUs, these kind of logics, if we repeatedly build these kind of logics, that is not feasible. So the invention or discoveries came here picture, like the complements. So for an example, if we need to subtract 5 minus 4, instead of subtracting this one, let's take complement for this number. So if we take is a decimal system, then if we take complement, then there will be some number will come, right? So let's add the r's complement or r minus 1's complement here. Okay, so r's complement or r minus 1 complement. So instead of subtracting it, we can use these complements. Complements means nothing but there is an exact transmission from plus to minus or minus to plus. So this is an exact mathematical, so exact English meaning, right? So instead of subtracting, we can take the complement for the second number and we can directly add it. So why we get is that we can take the complement and add it instead of subtraction. We can take a complement and add it, because if we take the complement for this number, then the sign will be reversed. So that is what the idea behind the complement. So here we have reduced a huge burden in a system. Like instead of going to the second logical operation or second kind of logical return, we have done it in the first logic itself. Okay, so multiplication, if you go to second thing, multiplication. So multiplication is nothing but repeated addition. We know that, right? So this will also come in the first logic. This will also now come in first logic. Fourth thing, division. Division is also nothing but continuous subtraction. So this is will also come into this one, because we can take complement and we can do it, right? So multiple of operations can be written and executed in a single code logic that will present in a ALUs. Okay, so we are reducing the system burden from multiple logics for each mathematical and logical operation. We are doing it. This is mathematical operation, right? So logical operations like or, and and everything that can also be done in this kind of addition itself, because in next lecture we will be seeing that or is nothing but a addition of two number, and is nothing but a multiplication, like that way only, right? So these can also be done in this logic itself. So this is why the complements are came into picture, that we can do any kind of operation with a single logic that is represented in or presented in ALUs. Not only addition, that logic can be anything, but in a single logic we can represent anything, like any kind of operations can be done here. So this is why we are going with complements. So we can use any complements, like for our system, mostly in our system everything has a r's complement only. So we will detailedly discuss why they go for r's complement, why not r minus 1's complement, why not signed digit. Everything will be detailedly seeing in the next lectures. So I hope you understand why we need r's complement. So today's lecture we have seen how to find the r's and r minus 1's complement for the binary and hexadecimal, and we saw an important discussion that why we need complement in addition, subtraction, or in a ALU operation, that we have detailedly discussed. I hope this is very informative for you guys. If you like the information that I shared, please like, share, and subscribe the channel, so that you guys will be get notified on all of my updates. Thank you. Stay tuned.